Hi there, I'm Hao, and this is just another video of me solving random code problem. So let's begin. Um, so given an non-negative integer representing the elevation map, where the width of each bar is 1, um, compute how much water can be trapped after raining. Okay, so we have 0 here, right? And then 0 here at index 2. So because we have height here, right? So the water can be trapped in between. So let worry about 0, it is 1, 2, and 3, right? Which is the height. And we can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, should be enough. So the first one is 0, right? At index 0, uh, the elevation, the height is 0. So this is index 0, right? The next one is 1. So we're up here, 1, right? Just index 1. And then the next one is 0. So we go back to 0. Right, this is index 2. Index 3 is 2. So we go up to 2. This is index 3. And then the next one is 1. So we go back down to 1. Back down to 1 here. And so this is index 4. And then we go back down to 0 at index 5. Right. And then next one is 1. Index 6. And then 3. Just around here. 3. Next 7. And then back to 2. Index 8. And then 1 to 1. Okay, so 1, 2, 1. So 9, 10, and 11. 9, 10, 11. Okay. So this is our hole, right? So the water can be trapped in between here, right? So on and so forth. Okay. So we need to keep track of our total water trap. Let's say we can have a water trap variable to keep track of the water being trapped. We can start at 0. So we know that the water can only be trapped in between 2 poles with the height of positive, right? It has to be trapped in between 2 poles with the positive height. So it means that we need to find the 2 pole to non-negative pole, right? If the whole array only have 1 pole that is positive, or 0 pole or positive, which means it is impossible to find the water trap, right? So we can find the first non-negative pole on the left and the first non-negative pole on the right, and we can use a Redi algorithm to calculate the water trap as we iterate from left and from right. So I can denote the green here as the left pole, right, and the red color here as the right pole. Okay, so we can find that the first the first non-zero pole is here, right? This is the first non-zero pole. Is at index 1 here, right? And off from the right side, the first non-zero pole is this one right here. Okay. So if they only have one pole, right? Which means the left and the right, the left pole and the right pole will eventually meet each other, right? Here and here. So if they only one positive pole, which means we cannot have water trap, right? In this case, we can just return 0. Right? Or if they have no pole at all, right? Which means the left and the right pole will be out of bound, right? So that is our three conditions. If the left pole or the right pole is out of bound, or if they equal to each other, right? Then we just can just go ahead and return 0 because there couldn't be any water trap. Okay, so after we find our first non-zero pole from the left and a non-zero pole from the right, it's time to find the water trap, right? So we can start our left pointer here and the right pointer here, right? So we always move the shorter one, right? We always move the shorter pole because moving the shorter pole give us a chance of finding a higher pole, right? Because the higher pole we find, we can find more trap water. So because now the length is equal here, right? 1 and 1, so we can just move the left pointer to here. Okay. So if the height at the left is smaller than the height at the left pole, then we can just then we know that there's water trap, right? If the height at the left index is lower, is smaller than the height at the left pole, we know that there must be some water trap. So in that case, we can calculate the water trap by taking the height at the left pole minus the height at the left index, right? Which is 1 minus 0 is 1, which is this height, right? So water can be trapped here. So this is 1, right? And now we are done, right? We can keep moving the left and the right pointer. We always move the shorter one, which is a left here. So left and go to here, right? And this is water trap. We already see it earlier, right? Define the water trap here. So now, after we increment the left pointer, now the left pointer has a higher height compared to the left pole, which means there shouldn't be any water trap because the left pointer is higher, right? So in that case, we want to go ahead and reset our left pole to okay, and we can continue. So we always move the shorter one. So right now, the high at left is 2, the high at right is 1, so we move the right pointer to here. Okay. So the right pointer, the high at the right pointer is higher than the right pole, right? So this means there's no water trap because the high at the right pointer is higher than the right pole. So we want to reset the high pole to here, right? Okay, and we keep going. So now because the left and the right have the same height, so I will just go ahead and move the left here, right? So because the height of the left pointer is lower than the height of the left pole, so there must be some water trap, right? Which is this part right here, this part, right? Which is 2 minus 1, which is 1, plus 1. So we have 2 here, right? And now because the left is have a lower height, we move the left to here, right? Because the height at left is again lower, it's shorter, right, than the height as the left pole here. So we know that there's water trap. How much? This part right here, right? Okay, so it's 2 minus 0 is 2, so we plus 2, right, which is 4 here. 4. So now, because the left is shorter, so we keep moving to left, right? And similarly, we can add the height, right, of trap water, which is 2 minus 1 is 1 here, so we have 5. Right, left is shorter, so we keep moving left. Right, it is 1, 1, 2, 1, right? So now the left is here. Right now, the left is higher than the pole, so we want to reset the left pole to here. Right. Right now, the high is lower than the left, so we can move to the right. Right, and now, because the high at the right is lower, is shorter than the high at the right pole, so we know it's trap water, right? This part, right, which is 1. So we add 1, right? So this becomes 6. So the right pointer is shorter, so we move the right pointer to here. Right. So the right pointer is equal to the right pole, which means there shouldn't be any water trap, right? Because they have been equal height. Right. So 2 minus 2 is 0. But so 6 plus 0 is still 6. We move the right to here. And now the left and the right overlap, so we just stop and exit them and return our water trap here 6, which is matched with our output here. Okay. So that is our general algorithm. We are doing it in one pass, so it's O of n, and the spray capacity will also be constant because we only use a few variable here. Okay, so let's code this up. So we need our left pole and right pole, starting at the two end, right? We want to find the new non-zero, find the non-zero pole for left and right. And so y, the height at the left pole is equal to 0. Right, we know that the minimum height is 0, right? We don't have to worry about negative number. And left pole plus plus. Similarly for the right, uh, 0 and 1 to minus. Um, no tap water, right? If there is less than 2 then false, right? Or less than 2 positive pole, positive height. Um, 0. Okay. So if the left pole is out of bound, right? Which is greater than or equal to 109, or the right pole is less than 0, which is out of bound, right? Or if they are equal to each other, if they are equal to each other, I mean there's only one positive pole, right? And we can just go ahead and return the water trap equal, right? So we need our water trap variable here set to 0. Okay. After that, we can find the water trap. Right? We can have our left and the right pointer equal to the left pole, and the right pointer equal to the right pole, and y left with less than right. right? If the height at left, right, is less than or equal to the height right, so we always move the structure one, right? Right. If it is less than or equal, we move to the left, right? Otherwise, we move to the right. Okay. So what do we want to do? So if the height at the left is less than the height at the left pole, right? Which means we have trap water. So if the height at left is less than or equal to the height at the left pole, right? Which means we have trap water. Which means we can go ahead and add it to our water trap, right? And what is the water trap? It's just gonna be the difference in the height, right? Which is the height at the left pole minus the height at the left. Right? And if it is and if the height at the left is greater than the height at the left pole, we want to reset our left pole equal to left. Okay. We do the same thing here for the right. Right. If the height at the right is less than or equal to the height at the right pole, there's water trap. So we add the water trap, right, to our water trap variable, right? And the water trap will just be the difference in the height. And then we, if it is greater, then we reset the right pole, right? And we can return the water trap again. Okay. And that was it. Let's give it a try. Okay. And thank you for watching.